Hey everybody, welcome to the video. Let's design a non-inverting amplifier using LTspice. Okay, so let's start a new file here. I'm going to add, right here you go to component, add an op amp. So you see right here there's a group called op amps, and look, there's tons of them. The ones here that's a universal op amp, they don't have all of the features that you need to run an accurate simulation. You need to pick one of these from some manufacturer. So this one is the AD8066, which I'm familiar with personally. I know it's a real product that works well, so you can feel free to choose the same one. Right, so I put that in the circuit. And op amps always need feedback, right? So I'm going to add a resistor. So up here, resistor, and you can rotate it. This button here is rotate. This one over here is mirror. So I just, here the hotkey for me is Control R. So I press Control R. Okay, now you can wire it, right here, wire. The output goes back through this resistor to the input. Which input? You're subtracting out error, right? So subtracting minus, it goes to the inverting input, the one with the minus, right? So now we have a feedback, an op amp with feedback. Now, what about the input? If you're building an inverting amplifier, the input would go to the inverting input. But in this case, we're designing a non-inverting amplifier. So our input should go to this one here. And you can adjust the amount by adding a resistor. So I'm going to rotate it. I'm going to put one feeding here and one where there's space here. Okay, so let me wire this here, this here, and the input is going to go to this, the one with the plus, right, the non-inverting. The other pin I'm going to just tie to ground here. And then right here's wire that. Oh, for the ground I just clicked right here. Okay, so now this one needs some kind of input. So I'm going to click here, component, and I'm just going to type voltage. Here we go. We have some voltage source here. And I'm going to wire that in. Okay, and don't forget, right here, ground, wire that in. Okay, here we go. Let's just add some values here. So for each resistor, I'm going to right click. So here, right click, just call that 1K. This resistor here, right click, I'm typing 1K. For this resistor here, right click, whatever, like 5K. Okay, so I'm expecting a gain of 1 plus 5/1. So I'm expecting a gain of 6. Okay, almost done. The op amp needs supply voltages here and here. And it needs a positive supply, negative supply. How do we do that? I'm going to add some voltage sources again, right here, component, voltage. I'm going to put 2 of them here. Okay, and now notice that, let me give it some values. So I'm going to right click, I'll just call it 10. Call this 10, right click, 10. Okay, so up here is 10 volts higher than down here. Or another way you can say it is down here is 10 volts lower than up here. So if I were to stick a ground right here and wire that, right, so now take a look. It's 0 volts down here and therefore 10 volts higher up here. So it's positive 10. So I can take this positive 10 and wire it to my positive supply pin. And now, check this out. it's 0 volts here. I'm going to tie it here. So where's the, up here is 0 volts, which means down here is 10 volts less than that. So it's negative 10. So this is actually negative 10, which I will feed to the negative supply pin of my op amp. All right, now one more thing. We need to specify our input here. So I'm going to right click. And if you just type a number here, this will be some DC voltage, but I'm going to click advanced and I'll give it a sine wave. And let's say you want to go, for example, an amplitude of 3. Right? What does that mean? And a frequency of, let's say, 1 kilohertz. So that means it's going between positive 3 and negative 3. But if you add some sort of DC offset here, let's say call that 1, right? Then it's actually going between negative 3 plus 1 to positive 3 plus 1, right? So it's a sine wave that's going between negative 2 and positive 4. And you can adjust these based on whatever you need. Okay, I think we're ready. So I'm going to click here, run the simulation. And there are different types of simulations. I'm just going to write this transient one. Let's see. So if the sine wave is going at 1 kilohertz, let's just go for a few milliseconds, say 3 milliseconds. And there we go. That's the simulation. But what do we want to show? So down here, when you move your cursor, this voltage probe shows up. So for now, I'm going to put the voltage probe right here, which is our input. And it is, as we expected, that sine wave. If you click right here, this cursor shows up and these numbers showed up. It was kind of off the screen for a minute. Okay, so look at this value right here. If you put your mouse cursor right here at the intersection of these two lines, you can drag this around. Right, so down here, look, it's at negative 2. And if you drag this, say, up here, it's at positive 4, as expected. Okay, now I am back down here. Can you see my mouse? Okay, so I'm going to, where do we want to probe? We want the output of this op amp, which is right here. So I'm going to click there. And what happened? Is that right? It is some kind of sine wave, but it got chopped off here and chopped off here. What happened? It's saturated, right? Because of the output can never exceed your supply voltages here, right? So let's say I'm going to right click down here and say this was a 50, like a very big voltage, and this is 50, so plus or minus 50. I'm going to rerun the simulation. Right, lots of room, right? And as expected, when we had a input here, let me zoom in. You can zoom in like this, right? So here, when the input is 4, the output is 24, so a gain of 6. But see this supply, my cursor is down here, right? So let's say this supply were 20 volts. We're expecting an output of 24, but if our supply can only provide 20, what's going to happen? I'm going to run the simulation. Look, it gets capped exactly at 20. As expected, right? So keep this in mind. This saturation, very important as an engineer, that you provide enough supply voltages for the circuit you're trying to build. Okay, so give this a try for yourself. Let me know if you have questions. I'll see you on the next video.